So the next law we want to talk about is using Newton's laws, and more importantly, using weight and I guess tension too. But don't worry about any of that. Well, obviously worry about weight and Newton's law, but don't worry about tension. The principle is simple. We're going to take a cart. We're going to run that cart with the string, cross a pulley, and then hang a mass. Okay? Okay? We're going to call this mass force applied. That's the applied force on the system. Okay? And we're going to accelerate this mass towards the end of the track. Now, what we're going to do if you're using the Pasco or the Vernier equipment, put a device over here, a motion sensor, to measure the acceleration of that cart. Okay? So you've got your cart, it's sitting on a track, and you've got a mass that's going to fall down. You're going to use this device to measure the acceleration. Cool? Now, what you're going to change, well, actually, there's a couple ways of doing this. If you look at Newton's laws and you say, well, sum of the forces is equal to mass times acceleration. That's the principle that we're going to apply. And the force that we're using to move this, to accelerate this object, is down here, what we call the weight of the object. So we can say, well, let's not call it force applied. That's stupid. Let's call it weight. Okay? So let's say that I've got my force applied. I'm going to say that's mg is equal to ma. Pretty straightforward. Okay? So I have two choices. Well, obviously, I'm not going to be able to change the acceleration due to gravity. But I can change this force. Okay? If I continue to add mass to that force, or to that object down here, I'm going to increase that force, which will increase my acceleration. Okay? So this m, I'm going to call it m1 because it can get kind of confusing with the two m's there. m1g is equal to m2g. Now the thing we're going to accelerate is this cart. Okay? Cool? So you can increase the mass here and see how that affects the acceleration of that cart. The other way you can do it, you've got to do one or the other because obviously you're only going to change one thing, is that you can increase the mass of the cart and keep your weight constant. If this number goes up or changes, then your acceleration goes down. You're still getting that same principle. You're still dealing with the exact same equation. So it's really your choice. You can either increase the weight here, or you can increase the mass here. You can add masses to increase the weight. You can add masses to increase its inertia, if you will. More inertia, less acceleration. Got it? That's what we're going to do for this lab. It's pretty straightforward. Well, hopefully it's pretty straightforward. We're going to use a cart, and we got two options. It's your choice. You want to increase the weight, you want to increase the mass. Okay? And what you're going to end up with is this term right here is going to be my y. This is going to be my, sorry, this is going to be my x, and this is going to be my slope. Okay? Cool? For the first option, where if you're increasing the weight here, this is going to be your y, this is going to be your x, and this is going to be your slope. Okay? That's the first option, where I'm increasing mass on this side, therefore increasing the weight, increasing that force, increasing my y. Got it? The other option, where if you're adjusting this term, okay, if your force stays constant, but your mass is changing, you're stuck with the same principle. Mass 2g, mass 1g, sorry, equals mass 2a. So this term is changing. That's the one I'm controlling. Sorry. This term is increasing, okay, and this term is decreasing. So those are the terms I've got to look at. So in order to get it in the y equals mx plus b term, I'm going to have to take one of them and move it over to the other side. So I'll divide by a, and I get m1g divided by a is equal to m2. Okay? This one's increased. 1 over a is increasing. So we've got that relationship. So that means that this is going to be my y. 1 over a is going to be my x. And then my slope should be the weight that I'm hanging from that end. Okay? So the first way, I'm going to recap everything so we get a little clearer. So the first method, you're increasing the weight. So you're looking at mg, this term being my y, is equal to ma, this term being my x, and this term being my slope. That's the first way. The second way, what I'm going to do in that case, I'm going to have 1 over a is equal to my x times, sorry, m1g, which is going to be equal to my slope, and my y is going to be m2. Okay? So the first method, I'm adding weight here, increasing the force applied. The second method, I'm adding weight here, increasing its inertia. Okay? Same force in the second time. I'm not changing any weight here. Got it? You can do either method. It's up to you. Cool? But if you're increasing weight here, or even when you're increasing it there, make sure there's small steps. You don't want to make large accelerations because you need enough data to get an accurate run. Okay? So make sure you're doing small changes on both of those. Got it? All right. That's Newton's first law, or Newton's second law lab.